Good morning. Guys sound a little trepidatious about our lesson today.
You got to the x equals L and
Yeah, it can't be that bad.
Oh, I think it can.
It's just logs. I was like, I'm like okay at those sometimes. On occasion. And my best thing is really at 98.
I don't think I did.
My math puzzle game is kind of good because this is my pre-health.
I think they would be better if we don't wait on him to eat on us and we just answer.
Where's that?
I think well, we can look. These things. Now, what would you do if you just sent the call? What would you do? You're absolutely. That would be the first. I have no clue. Oh, shoot.
What? Oh, you didn't see the warm-up stuff?
Hey, Ellen White, man.
Yeah.
Donna, you have to use your log now. A log C of B is equal to log C of BA.
Dude, what? What did you just say? These guys spells or something?
This
is you imagine you're saying.
If you were looking at it, you can find. Yeah.
Oh, yeah.
It was.
You just said that outside today.
Well, I don't have that. As opposed to I could not believe she did that. Good morning. How's everybody doing today? Any of you juniors in here, you guys want to talk about what classes to take next year? Especially going into your senior year, getting ready for college. We're more than happy to sit down and talk to you about what you can expect, at least from a math standpoint, mildly from a science standpoint, as I do have a chemistry background. So we could sit down and talk about that. I know you guys just got your registration cards yesterday or today, right? So any of you that want to sit down and talk about that, be more than happy to talk about what, obviously you're in calculus, we can talk about stats and talk about whether or not that would be something useful for your career. The quick answer to that question is probably yes, but nonetheless. Yes, sir. Give us just another minute or two. Work on our logarithms. Work on our logarithms. So gang, I have a question for you all. I'm gonna let you guys decide, which is scary. Do you want me to put your Unit 4 quiz on this grading period, the one that is about to close? Do you want the Unit 4 quiz on this, yes or no? Your Unit 4 test, without a doubt, is going on your next grading period, without a doubt, along with your 4.4 and 4.5 homework. Those are the only grades that I have stacked right now, waiting for that. I have your quizzes graded and done. You all can see your grades, I think, on Canvas of what I've given you. I can put in the homework, 4.1, 4.2, 4.3 homework, and the quiz all into this grading period right here, right now. Good, bad, and indifferent. Or we can bake them and let them go in for next grading period. As I have tremendous respect for you all as young adults and your work ethic in here, more so than I've ever had for any other class, and I mean that 100% candidly. I've never taught some of the students as many times as I've taught some of you. Looking around, like, oh, for instance, Mr. Burr, you and I have had how many classes together now? 4, 5? So I trust in you all. Trust in your opinion and your judgment. Think about it, and we'll come back to it at the end of class, and we'll decide what we want to do. I want you guys to have an input on it. That's why I've held off. I was thinking about it last night before I actually started putting them in. I thought maybe I should ask them what they want to do. If I put it in, I wouldn't expect significant changes. Good, bad, or indifferent, I wouldn't expect any significant changes. You have a massive amount of assignments already listed for this grading period. You have close to 30 homework assignments, so 3 more is not going to make a huge difference. You already have 6 quizzes, so adding a 7th is not going to make a big difference. And I'm not adding a test, which is what would make a significant difference. We're not doing that. So it could, if you put it off to next grading period, it can help pad where we start, very similar to how we had our project, our fall assignment, that helped us start off on the right foot for this grading period. If we pad them and we've done well, then it can help us start off next grading period a little bit stronger, just in case we struggle with Unit 5. I will also say that after Unit 5, we are all going into some uncharted territory. You see, Unit 5 is where calculus ended last year because I had to take a legitimate full month off of teaching. And the AP calculus test was like one of the very first AP tests given in May. So after we finish Unit 5, we will officially begin lessons that Mr. Kaufman has not taught at least once or twice before. You guys will truly become the guinea pigs for the first time in a long time for some of you. Now that I think about it, the first time in a really long time for some of you. And some of you will be the first time you're ever seeing Mr. Kaufman teach something for the first time. Forewarning, there will be several mistakes, I'm sure. Questions here? I'm excited about it nonetheless to get into some new material I haven't gotten a chance to do yet. I will say that this unit 5, I kind of think about it very simply as logarithms and trig, or as you might want to think about as like kind of more of our advanced functions meets calculus. More of our more advanced algebra and geometry meeting some of our integrals and derivatives. That's what we're going to talk about in this unit. Majority of it is focused around logs and exponentials. We will also talk, of course, a little bit about trig towards the very end. Things like arcsine, arctangent, or inverse sine, inverse tangent. We'll talk about those towards the very end. Questions with any of this? This might fluctuate on how many days. Right now, I think we should be able to get every lesson done in one day, so I don't have any of them stacked out for 2. But if for some reason we're struggling with any of these, if we're having issues with our pre-existing knowledge, then we'll talk about those as we go through. Okay? Now, the good thing is as we talk about some of these, I think a lot of the rules are very easy when it comes to some of these. For some of them, they're a little bit more complicated. But I think the majority of the rules are relatively easy and straightforward to apply. First thing we got to do is remember how to deal with logarithms. Who wants to help us get started here with one of my warm-up problems? Mr. Moore, which one would you like to do? 1, 2, or 3? 1. What are you going to do first, sir?
We are going to bring up our coefficients.
We're going to bring up our coefficients. We bring them up as exponents. So this becomes the natural log of x squared. This will become plus the natural log of
X squared and then 5.
Okay, so let's just put them together, make it 10.
And then
Minus the natural log of y cubed, yes? Okay. How do we do the adding and subtracting parts? Do you remember?
we're going to multiply, or we're going to add our exponents, right?
Oh, yes, we will. When we add logarithms, we're really going to multiply the interior, right? So if I want to focus on these two first, we're going to look at the natural log of x squared times x to the 10th, and then minus the natural log y cubed, right? Which is, yes, where we'll go ahead and add those exponents up and make that x to the 12th, correct?
Right.
What are we going to do with subtraction?
We're not going to put x over y.
We're going to put x over y. So natural log x to the 12th over y cubed, and that is my condensed logarithm. Questions? Bringing back some familiarities. Should. I know that I taught all of you this in pre-calculus. We do a very large logarithms and exponential unit, and I had all of you in pre-calc, whether it was just last semester or it was last year. And I do know for a fact this was taught live. This was pre-COVID, if you can remember back when dinosaurs roamed the earth and coronavirus was not a thing that we were all concerned about. Let's move on to our second warm-up problem. Who wants to help us out here? Allie?
Can I do number 3?
Yeah, we can skip to 3 if you'd rather do 3.
Do you do the power rule again?
Yep, we are. We're going to start with that at least. Log x to the 4th minus log base 10 x to the 10th, correct?
And if the first one's log base 10.
Absolutely. This is a common log, right, which we assume has log base 10. So these two can actually go together. So this is going to become log x to the 4th over x to the 10th. And our last step here, Allie, is,
You can cancel out the
so I got log
1 over x to the 6th.
1 over x to the 6th. Questions here? Awesome. One other way we could write this is log x to the negative 6th Correct? Issues here, concerns here. Okay, that takes care of number 3. So back to the other one. Who wants to help us with number 2? Well, come on now, gang. The people at home are probably getting bored. It's an AP class. Come on, step up, show some bravery. You know I'm not going to leave you out there to dry. You didn't get here because you're bad at math. Nobody's going to think you're dumb or anything. Come on. Have some courage. Dom, I love it. What are we going to do?
Okay, well, the first thing, you can still use your power rule, right?
Absolutely, I can.
So you take your natural log of x plus 3, and that's the quantity to the 1/2.
Quantity to 1/2. I'm glad you specified the quantity there. Absolutely.
So then you can do your minus your log of your 2y plus 1. That's the quantity of 3/2.
3/2. Okay. Dom, let's go ahead. Let's convert these roots, or convert these back to roots. Okay?
Yeah.
Now, if we were doing, and what we'll probably talk about later on when we do our actual calculus and our derivatives and our integrals, is typically we don't do calc and integrals, derivatives, and all that with roots. We normally convert them over to exponentials. So this would be one of those things where we may or may not go to a root form as we look at our rules today. But for right now, let's do it.
Okay, so you have the natural log of the square root of x plus 3.
Minus the
The
common log, right?
of what is it, 3 root 2y plus 1.
This is going to be square root of 2y plus 1 quantity cubed. That 3 goes inside, right? And can I put these logs together? No, because they're not the same log, right? This is a natural log or log base e. And this is a standard log with the log base 10. Questions? So, I will forewarn you. These two functions are done differently in calculus. There are different rules that apply for natural logs than there are for rules that apply for standard logs. So we will talk about the differences between them. If you're looking at your Canvas course, I have a whole day for bases other than E. So we are going to do almost everything we're going to focus on at first. We're going to lay all the foundational pieces for using natural logs, LN. And we will work our way back to these logs where we can change the base to something other than this. Okay? Questions? Issues? I don't know why we hesitated to do that one for so long. Dom, you had no problem with that, man. Good work. More confidence in yourself, sir.
I thought you were going to pull a sneaky on me and tell me we can combine those. So I got scared because I didn't know how to do that.
Ow. Not yet. It's only day 1 of the unit. Give me some time. Let me lull you into a false sense of security first. What was that, Luke?
I said, that's not cool.
It's not cool? Once again, this ain't your first rodeo with me. You should always expect it.
Yeah, that's why no one went into that one.
All right, let's go ahead. Let's get into what we're going to do here today. Let's take a look at our notes. We're going to start here talking about logs and calculus. I'm going to take just a little bit and refresh our memory here. We seem to do pretty well with these, but I'm going to just make sure we're all on the same page about natural logs before we get into it. So just a little bit more practice here as we get started. So let's go on to off of our title slide here on to slide 2. This is our homework. I started putting it at the beginning because sometimes I forget to actually show it to you all. At least I was doing that earlier in the year. Somebody told me that. So here it is. Okay, let's go ahead. Let's jump into this here. So slide 3, some basic properties of natural logarithms on slide 3. So on slide 3, these are continuous functions. They are continuous functions. They are continuous on the interval 0 through infinite. 0 through infinite. You cannot put 0 into a logarithm. You cannot do the log of 0. So this is a parenthesis 0 through infinite. That is our domain. Our range here is unbounded, negative infinite through infinite. These are inherently single curves, so they are concave down traditionally as a parent function. They do increase over time normally. So our second derivative test here would end up being always negative with no inflection points. Our first derivative would be always positive with no critical numbers. This is a one-to-one function. You guys remember what one-to-one means? Every x spits out a specific y value. Every x has only one y value that it can spit out, meaning that it would pass the vertical line test. This function is also what we refer to as onto, meaning that it would pass the horizontal line test, which means every y has only one x value. A one-to-one and onto function. If we have time in later units, we actually might talk about why that's important. So I'm a little excited to see if we make it that far this year. Some basic properties that we've already used up there. We have our product property that we used, our subtraction or division property. Quotient property is how I teach it in pre-calc. And our power property. So those three we've all used. I didn't use the first one, which is the natural log of 1 is 0. The natural log of 1 is 0. Just a quick review of the basics of a logarithm. Keep in mind, back in pre-calc, this whole slide is an entire lesson all on its own. I get into the graph and do all this stuff here. Are we all comfortable here with slide 3? We know what to expect from our derivatives, from our integrals here. We can already start thinking about our first and second derivative test, which we will eventually do. We're all comfortable here. Okay, so I did some condensing for our warm-up problems. Let's move on to slide 4. And I would like you to do the opposite. I would like you to expand these 4 logarithms. So go ahead on slide 4. Do them quickly. I would like you to expand these logarithms. We'll go through them relatively quickly here. It is important and it is absolutely necessary that we can expand and contract logarithms for us to do our derivatives and integrals of. It is absolutely necessary for us to be able to do this, just as much as we've talked about the basic necessary skills of manipulating roots or fraction equations and things like that, as we've looked at the past couple of units. We need to be able to manipulate these just as much. First three should not take you very long to do. The last one might take you a second. Last one might take you just a minute. We'll put our answers up for us here so that way we can start checking what we've done. Put our answers up here so that way we can start checking what we've done. Who wants to help us out here? Don. I'm not going to do the first one. It's pretty straightforward, I think. We're just going to separate those using the quotient rule. Which one would you like to do? 3, 4, or 5? Or 3, 5. 2, 3, or 4, sir? Do the last one. All right, stepping up to the hardest problem. I like it. What did you do first, Don?
The first thing I did was, so you have like the top part squared, whatever, I just brought that down. Oh, well, actually, I split the logs first.
Well, I think the first thing we should do is split up this
That's what
this mess here.
So I have a ln of a
Natural log, let's not use
Yeah,
ln, let's call it what it is. Natural log x squared plus 3 quantity squared.
minus natural log of x to the cube root of x squared plus 1.
Did you leave this as a root or did you switch this over to a rational exponent?
That was my next step.
Okay, so let's do that now. Let's kill 2 birds, 1 stone here. As we rewrite it, let's go 1/2 here. Okay? Is everybody comfortable with that? Okay, Dom, next thing you did?
I started using my power rule in reverse, so I brought the.
I see where one instance we can do that. I don't see 2. I see that I can bring this one down to natural log x squared plus 3. I don't want to start doing the power rule over here because those are not the same power. What's more is that whole set, the product here of these two is not being raised to an exponent. So if I want to bring down exponents here, I need to separate those two before I do a power rule. before I do my power rule. This needs to be broken into natural log x cubed plus natural log x squared plus 1 to the 1/2. Those must be separated from each other before we can do that power rule. I now realize I'm missing a 3 in my answer there, but that's okay. I'll fix it in a second.
No, I think you made your x cubed instead of making a cube root. Your first x there.
You're right. Mr. Kaufman can't read his own problems.
Yeah.
Thanks, Dom. Still, we're going to need to separate that.
Yeah, so
1
it's still
third.
a third.
Still, we need to separate that, and then we can do our
Then you do your power rule.
Power.
So you bring your 1/3 for the last natural log, and that's your final answer.
absolutely. Either way, before we bring that power down, we do still need to separate, because this is still x to the first, and it still doesn't match one way or another. So plus 1/3. Thanks, Dom, for setting me straight there. Appreciate it. One of the drawbacks here is very often our tech is not meant to do calculus. Nobody makes education technology really for calculus, and if you do, chances are your school is not willing to pay for it, like ours. So we make do with what we got. Dom, awesome job here with the last one. I do think that is the most difficult one. Anybody want to try one of the ones above? Ryan, which one would you like to do, sir?
Number 2.
Number 2. Okay, Ryan, let's do number 2 then. What'd you do for number 2?
I changed it from the root to the power.
So we got 3x plus 2, correct?
Right.
To the 1/2 power, and then we did what?
I brought it outside.
Natural log 3x plus 2. Now you could leave this 1/2 out here just as a constant, as a coefficient, as a multiplier. You could also rewrite it as one large fraction all over 2, like this. So you will see both represented. So I want to make sure that if you see a log with a denominator, you think, okay, I can move this and make it into a coefficient and then move it up as a power as well. Likewise, if I need to get rid of a coefficient, we can do this as well. Questions here? Okay. Do we need to do 1 or 3? Do we need to do 1 or 3? We're comfortable, we're good? Okay. So, let's move on. Let's get into what we want to do here today, which is some calculus with some logarithms. Let's do some calculus with some logarithms. Let's move on to slide 5. So slide 5, the basic derivative property of a natural log. The basic derivative of a natural log is 1 over x. Now the true form of this is actually a chain rule. The true form of this is actually a chain rule. It is 1 over x, that is the natural log, that is its derivative. We must multiply this by the derivative of what is inside the natural log. So technically, the second example here is probably a little bit better example. We'll take the 1 over u times the derivative of u. That's typically what we're going to be looking at here. This also holds true if there's an absolute value involved. This will also hold true for the absolute value of the logarithm. Questions here about these? So this is very, very, very similar to your chain rule. In fact, it is your chain rule. It's just that you don't know how to do the derivative of the first function, which is the natural log, which is just going to be 1 over the number inside the logarithm, 1 over your argument, as what we would say, because that is what that is inside. That's its proper name. It's the argument of the logarithm. It's what's inside. Questions? It should be relatively straightforward to use. So what we're going to practice today is just doing the derivatives, pretty much using this in a lot of different settings, combining this with things we already know how to do, like implicit differentiation, like first derivative and second derivative test. We're going to be mixing this in with the things we've already talked about, which is a lot of things when it comes to derivatives. So we're going to start off small scale and work up to our more difficult ones as we go. Sound like a plan? Awesome. Let's move on then from slide 5, which is our most important slide of the day. And let's do a problem. Who wants to help me? Who wants to help? John. John will start by copying down the problem. I got the natural log of 2x. And I want to take the derivative, d dx, of the natural log of 2x. Okay? So, let's start with the fraction part. This is going to be 1 over 2x times the derivative of what's inside. What's the derivative of 2x? 2. Okay? When we reduce down, what's it going to be? X. It reduces down to be 1 over x. Questions here? Concerns here? Feels too easy, doesn't it? Remember what I said about that false sense of security? No, I'm just teasing. Today should be a relatively easy day. Like I said, we're just going to practice this new relationship, and we're just going to start combining it with other things we already know about derivatives. So we're going to combine this with its product rule, with quotient rules. We're going to put this with, like I said, derivative test. We're going to do implicit differentiation with this. We're going to go back to all of those things we did in Unit 2 and in Unit 3 and just mix this into those to make sure we're still comfortable and also that we remember how to do those things. If you're worried about doing those, I will tell you the first few problems I have here are definitely easier than the last sets of problems I have here. So those that are normally pretty trepidatious about being involved, I would encourage you to step up sooner rather than later. There's our next one. Take a second, look it over. Take a second and look it over. So the people I have yet to hear from today are Michaela, Todd, Dawson, Caleb, Anne Marie, and Parker. And if you guys want to step into it, Michaela, let's go ahead and let's start. First thing we're going to do is the fraction for the natural log, right? What is that fraction going to look like? Okay, very good. We need to multiply by the derivative of what's inside the log, which is 2x. And we'll simplify. And I'm going to get 2x over x squared plus 1. Anything else I need? Do we feel okay with this? Let's check it out. Let's see if our work here. Okay, so looks good for me. That's what I have. And then we simplify it down to 2x over x squared plus 1. So that's our next problem. All set and taken care of here for slide 7. Issues. Meltdowns, concerns. Okay, let's move on to our next problem then. On to slide 8 we will go. On to slide 8 we will go. And then there was 5 students I hadn't heard from yet. As they all avert their eyes from me. Parker, you want to step into it? Sure. Parker, when I look at this one here, what I see, sir, is 2 options we can do. 2 options for the way that we can do this. Easiest way, I think, might be to look at this and say, this is a product. Look at this and separate this as a product. Well, I have a function times a function here, right? So I can do f. I would make f's derivative, of course, 1. I could do g. And that would make g's derivative 1 over x, correct? And then we could set up our product rule. Would you like to do it that way, or would you like to use our properties of logarithms to see if we can do it another way?
Product rule seems way.
Okay, then let's do that. And then I'll go back and show the other way. So, Parker, product rule, of course, is going to be g times f derivative plus f times g's derivative. We got all this stuff. Let's plug it in. Okay? So, f or g here is natural log of x times f derivative, which is 1, plus we have f, which is x, times the g derivative, which is 1 over x. What's going to happen here, sir?
The x's will cancel out and it'll just be 1.
Plus 1 and...
It'll be natural log x.
Very good. Let's double check Parker's work here with the answer. So I went product rule on the slide because I do agree with you, sir. I think that is a much easier approach than the way I'm about to show. And it reduces down. I wrote it as 1 plus natural log of x, but it doesn't make that big of a difference. The alternative way here is to use our power rule. You could go d dx of the natural log of x to the x power, which would be, the natural log would be 1 over x to the x power, times the log of what's inside, which is going to be x times x to the x minus 1. And believe it or not, that reduces down to be natural log of x plus 1. Do you guys want to see me do it, or we're going to take Mr. Kaufman's word for it?
No, do it.
Do it?
Yeah. Do it.
How much time we got? What time is it now?
It's 10:50, so we got 45 minutes.
Oh, I don't know if we got time for me to do it. Maybe later. If we got time, we'll come back to it. But I don't know. I don't know if we got time to finish our lesson, let alone for me to go on a algebra adventure. I'll have to put a little star next to this one. Come back to it if we have time. Let's move on to the next slide. Next problem. And then there were 4. Anne Marie, you want to give it a shot? Appreciate you, miss. What do you want to do first with this problem here? We have the natural log, we have all of that quantity to the third power. What do you want to do first?
Could you do a chain rule, or would you have to bring the 3 down?
What did you do?
Was thinking about doing the chain rule.
Okay, well, the chain rule would be the derivative of the exterior, right? Which would be 3 times the natural log of x, and all this would be quantity squared now, right? Times the derivative of what's inside, which would be
Would be 1 over x.
1 over x, because that's the natural log, and then of course the derivative of what's inside the log, which is just x, which is just 1, right? Okay, so according to doing it this way, you would have 3 natural log x quantity squared all over x, right? Let's check and see. What I did. Just apply the chain rule. Now there is another way that you could do this. There's another way. We could expand this out a little bit. This is the same thing as natural log x times natural log x times natural log x, correct? Yes? No? Maybe? Okay. Or we could build off of Anne Marie's work. We could go one step farther with her work too. We can actually take this 2 and bring it down and make this 6 natural log x to the x power. As this would be natural log of x squared, because that's how we would combine those logarithms. Both are good here. I would take where you left this, Anne Marie. I would. I wouldn't push it much farther than that, because there's not any real advantage to making this 6 versus it being 3 natural log squared. There's not much major advantage to that. It's more kind of problem by problem on how we want to go forward with that. If I had something that I want to maybe simplify in the denominator, say that's not just 1 over x, say it's, let's say 1 over 6x, then I would obviously want to bring that down so that way I can cancel the 6's. But otherwise, we're going to have to play that a little bit by ear. But good work here, recognizing the chain. Let's go on to the next slide. Go on to the next slide. So, find the derivative of this function. Find the derivative of this particular function. Let's help out. Boys, there's only 3 of you left. Todd, Dawson, and Caleb, who's going to do it? Todd going to do it? Okay. Todd, let's step into it here. What do you want to do first? Yeah, I would go ahead and change this over to a rational exponent first, right? So x plus 1 to the 1/2, okay? Which will make doing what you're talking about there, I think, just a little bit easier because obviously, as you just said, we're going to go with 1 over the square root of x plus 1, but I'm going to keep it, you said to put it back as a root, so I'll put it back as a root. But the reason why I'm going to rewrite that is for the next part here, of course, when we do the derivative of the interior, right? Okay, what is the derivative of the interior? 1 over 2 square root x plus 1, right? Well, let's find out. If we multiply them together, right? Of course, we're going to keep the coefficient out in front, 2, right? 1 over 2. And any root times itself cancels the root. It just leaves me back the radicand, which is x plus 1, correct? So we're thinking, let's send it 1 over 2 quantity x plus 1, or 2x plus 2 is Todd's theoretical answer. I like it. Questions? This is one that's, as you expand it out, starts to look more complicated, but as you reduce it down, it reduces very nicely for us. Okay, let's go ahead. Let's look at our next slide here. What slide are we on? I lost track. We're on moving on to slide 11. Moving on to slide 11. Find the derivative of this monster. And then there were 2. They're going to be Caleb or Dawson is going to help us out here. Now, there is an easy way to do this problem, and there is a difficult way to do this problem. I am curious to see which way we pick. And given our time restraint here, I think if we don't pick the easy way, I'm going to guide us to it. Boys, who's doing it? Dawson stepping up. Dawson, how do you want to attack this problem?
So would you, I don't know, this, I guess it could be an easy way, just break it up, like, yeah, just break it up into natural log, like with the product and division rules, is that what?
Like making multiple natural logs? Yeah, I think that is absolutely the best way to do this. I think that is absolutely the best way to do this. Sure, right now, the first step would be easy. We'll flip the fraction, right? Everything after that becomes a nightmare because you got a product rule on the top of a quotient rule when you go for what's the derivative of inside the logarithm. And on top of those, you have multiple chain rules. I think it looks like a nightmare if we try to leave it alone. I think if we break it up, we'll have a better chance of treating each log individually and having an easier time with that than trying to do it as one log. Sometimes that works the opposite way too. Sometimes you will want to condense logs to make them into easier ones to deal with, especially if you see things that will cancel as you do that. So that's why I made sure today for us to do both expanding and condensing logs so that way we could practice that. Okay, so Dawson, let's expand this thing out here. We got the natural log. Let's start by breaking the quotient there. X quantity x squared plus 1 squared. And then minus the natural log of the root 2x minus 3 to the first. Okay? Now what do we want to do?
Can you break up the first natural log?
Yeah, I break this one up. Natural log x plus natural log x squared plus 1 quantity squared. Do you want to leave this as a root, or do you want to convert that over to a rational exponent?
Convert it over.
I think convert it over because John asked a question here about the last question that I'm going to point out now. Now, we did it straightforward from this on the last one. That's what Todd did when we looked at the root problem on the last slide. If I go back real quick to the previous slide, Todd went straight forward and just did a chain rule applied, which worked just fine for us, right? Okay, there is an easier way to do this, though, and that's to apply our power rule instead. So, Dawson, entertain this with me here. Let's do our power rules, and then we'll do the derivatives. If I do the power rule here and here, it will make each of these significantly easier. Natural log x squared plus 1. 1/2 natural log 2x 3 minus 1. We are now going to do the derivative of each of these individually. And when I do this derivative, Dawson, this is just a constant multiplier, right? So I don't have to do that as part of the derivative. I can remove that and multiply it through after, right? So that's what we're going to do rather than having to do two roots like Todd did on the previous problem, which was nothing wrong with the way we did it, Todd. We got the right answer. It's just that this is a little bit smoother. Dawson, let's do each of these. The first derivative is going to be 1 over x. We're going to have 2 times, what's this derivative going to be? 1 over quantity x squared plus 1 times the derivative of what's inside, which is 2x, minus our 1/2 times 1 over
2x cubed minus 1
times the derivative
6x squared.
6x quantity squared. Glad you grabbed the square there. A lot of people will just tell me 6x. Good work. Okay, now we just need to simplify some stuff down, right? Okay, well, this is 1 over x. This is going to become 4x over x squared plus 1, correct? And this is going to become 1. This is going to become 2 times 2x cubed minus 1, correct? And that's 6x squared going on top. So far, so good with what I've done to reduce.
Sure.
Okay, anything else I can do? One last step, maybe? Yeah, I'm gonna reduce those down and make that 3x squared, correct? Questions here? Issues here? Let's double check my work here. So for our work for this slide, I started by breaking the quotient and then expanding and then doing our power rule for each and every single one. Now, you don't have to do the power rule. You could do it as a chain rule. So that's why I didn't explicitly show the next step I wrote there, because you could do it the way Todd did the last one, which is a chain, or you can do this power rule and bring these multipliers down. Generally speaking, I think it works better to bring the powers down and treat them as constant, but to each their own. Either way, our answer here looks good to us. I like it. I think it looks really nice. Did a great job here with this problem. Issues here, concerns here. Make no mistake, I think this is a very fair question for a quiz or a test. I think all of the previous ones I asked you, don't get me wrong, I'm sure that they're fine for a quiz or a test, but quite frankly, they're kind of too easy. This one I think is a pretty good, appropriate level 1. Okay, let's move on. Let's move on. Next slide, next problem. Caleb, your problem here. Your problem on slide 12. Take a second. Let's look it over. Caleb, ready? Let's do it then, sir. What we're going to have.
So, is it the same as if there was no absolute value?
At least the first part would be, yeah.
So it's 1 over cosine x.
1 over cosine x. And then, of course, we need to multiply by the derivative of what's inside. What's the derivative of what's inside?
Negative sine x.
Okay. Okay, so what's our final answer?
Negative sine x over cosine x.
Keep going. There's one more step there.
Negative tangent.
Negative tangent of x. Questions here? Concerns here? Issues here? Not a very difficult one, but one if we overcomplicate it, definitely could sneak up on us. Okay. So now I'm going to open it back up to everybody or force everybody. Move on to our next slide. So let's start mixing it in. We did a bunch of generic find the derivatives, so let's start mixing it in with some other things. I want you to find the extremes of this equation. I want you to find the extrema of this equation. All of that, by the way, is inside that logarithm. All of the x squared 2x plus 3 is inside that logarithm.
You're ready for what you got done.
That's fine.
But, what is that? I've asked you to get that. I want to know what it is. Okay.
Longer than that.
You do it.
Yeah.
How are we feeling about this one? Not so spicy. Unfortunate. Anybody got some ideas? We should at least know what we need to do. We might just have some problems with executing it. What do we need to do? Alex?
So you do the 1 over the x squared plus 2x plus 3, and then multiply on the 2x plus 2.
What are we setting up?
To get the derivative.
Why?
Because you have to do the first derivative.
We're going to run the first derivative test. So yes, we're going to get the first derivative because obviously we need that for our first test. Okay, so getting the derivative here, what's it going to be, Allie?
Equals 2x plus 2 over x squared plus 2x plus 3.
Okay, so we'll run our first derivative test. This is our first derivative of x here, right? So what are we looking for?
When the 1 equals 0.
When it's going to equal 0 or be undefined, which would mean when equals 0, of course, that's 2x plus 2 equals 0. That gives us x equal to -1. Is there any point where this is undefined or does not exist, aka x squared plus 2x plus 3 equals 0? No. This has two complex answers, which we're not going to deal with here. This is not factorable. And what's more is it does not have real solutions in the first place. So we are going to focus on the -1. What are we going to do with the -1, Allie?
You put it on your number line.
Put it on my number line.
And then you plug in -2 to the derivative.
Okay, so you have -2. -2 works just fine. -2 is going to spit out what on the top here? That should be -2. And then in the bottom, -2 is going to spit out 3. Positive 3, right? Okay, so that's negative here. What about the other side? 0, and that's going to give us 2/3, and that's positive. So we're going negative to positive. That means -1 is a min. And if we really want to be thorough about it, where would we go with -1?
You plug it into the original.
Okay, and that would give us a 1 minus 2 plus 3. That's the natural log of 2, which you can either punch in the calculator or just leave it as natural log. It's going to give us a less than pleasant decimal. Everything here that Allie's described looks good. Everything that Allie's described here does look good. There is no x value that generates. It does not exist for our number line, so we're only looking at -1. It is negative to positive, which implies that this is a minimum at -1. If we truly want to be thorough, I shouldn't have a apostrophe there, that's a typo. We really want to be thorough, we can say it's at -1, natural log 2 is the actual minimum value we have. Questions here? Issues here? Meltdowns? Parts of this we're unfamiliar with? Okay. Onward then to my last slide. This is why I said I don't think we have time to do all of these today, because we're almost out of time already. We only got 15 minutes left with class here. So I'll tell you what we'll do is we'll go ahead and we'll save this for another time. We'll save these problems for another time. I'll let you have this 15 minutes to start your homework and to answer my question that I asked at the beginning of class. Do you remember the question I asked at the beginning of class? Where do you want Unit 4 to start? This 9 weeks or next? Parker.
I was wondering if you can split the quiz, like keep the quiz on this 9 weeks and then put the homeworks on the next 9 weeks?
I cannot. If I'm going to put the quiz, then I have to put the homeworks prior to the quiz on.
I don't see.
I could program it that way, but I will hear about it from administration. And I prefer not to have a conversation with them about it, because they're not gonna like that I probably asked you guys and let you guys decide in the first place. Other feelings? John?
I don't see the grade.
I can't tell you that. I can't tell you how it's gonna affect your grades individually.
No, I'm saying like in the dashboard.
Oh, you can't actually see it in there. Oh. That's weird. Let me see if I can guide you to it.
Yeah, I kind of want to do this one. I just want to go.
I tried this bad on it.
Yeah.
Let me double check. Let me double check.
I got really confused.
Where did I? Here, let's go back to our homework slides, that way I can put that up now for the screen. Huh. Well, that makes it easy. I graded them last night, but it didn't keep anything. That sucks. That absolutely sucks. That was like a waste of 2 hours of my time. That's fun. Well, the decision's been made by Canvas Forest. They're going on next 9 weeks. They're going on next 9 weeks because unfortunately, the grading I did last night didn't keep. None of the comments are there, none of the grades are there. I gotta redo it. Sorry. I've tried to let you guys have a little bit of input, but Canvas had other ideas. All right, well, let's take this time. Let's get started with our homework here. And just a reminder, tomorrow, your only assignment is to finish your Unit 4 test, right? That's the only assignment tomorrow. Get it done, get it turned in. And Thursday, we're not going to do another lesson. We're going to save 5-2 for next Monday. So you guys actually are going to get 5-2 yourselves. And we're going to do a little reflection. Okay? Dom, a question before we wrap up?
What happened to the one problem that you were gonna do? The hard one? You got 10 minutes.
Let me end the stream and whatnot, and I'll see if I can get it done.
I think you got it.
I don't know if I do. Let's go ahead and end our stream here. Because I don't really have 10 minutes, because I